Hello, everyone. Welcome back to my channel. We are talking about AI regressions, the regression model of predicting the values of the variables. In the previous lecture, we talked about linear regression. Just a brief recap. In linear regression, what we had was predicting the value of one variable depending upon the value of another one. So it was just one-to-one relationship. Okay. So when one variable changes, how does it affect the value of the second one? That was linear. Today, we're going to talk about multiple regressions because in real life, things are not that easy. So let's say we are studying about recession, economics, so many things. It's not just one factor that can help us predict the value, like whether what will be the price of this X after X amount of time, or anything such like that. Okay, there are multiple values that play into effect. So let's say if it's going to rain or not. So many factors affect whether it's going to rain or whether it's going to snow. It's not always one to one. So we cannot use linear regression in those scenarios. There, multiple regression comes in. So again, it's a statistical technique that uses several variables to predict the outcome of one. So say, for example, if you want to buy a house and you want to predict what would be the value of the house. So you have so many things to take into consideration, right? The number of bedrooms, square footage, how close is it to schools, how close it is to other convenience thing like markets, supermarkets, or any other things, right? Number of bedrooms, so many things play a role in determining the value of a house, right? So that is multivariate regression. So here, this is an example. Now, how it is computed. Again, this is for knowledge purposes because you won't be actually doing it. When you write code in Python, the underlying function that you call it, and underneath it, it's doing it. So here, y hat is the predicted value of the dependent variable. So if we are using housing price as an example, so y hat would be the price of the house. And this is the intercept. B0 is the y-intercept. Okay, what is the intercept? It's the value when all of other depending values or predicting values are 0. So when x1 is 0, x2 is 0, x3 is 0, when everything is 0, what will be the value of this? So the first one is the intercept. These are the regression coefficients, which means how much value does each one has, okay? Representing the change in y for 1 unit change in the corresponding x. Okay, so it's kind of weight, like how much this affects, how much this parameter affects the value of y. Okay, not every parameter has equal effects. Say, for example, number of bedrooms has more impact than the price of on the price of the house than its proximity to school, right? Proximity to schools is nice to have. So let's say if you are an elderly couple, your kids are not going to school, so it's not going to affect, right? The price of house so much for you. So each variable, so this could be number of bedrooms, proximity to other things, supermarket, malls. This could be something else, proximity to schools. One more thing would be, say, proximity to your work. And how much weightage does it have? When everything else is 0, what is beta b? This is the beta sign. What is this? This is the intercept, and each of these are the coefficients. And then there is an error term, that is the difference between the actual and the predicted variables. Like what actually it is and what your model predicted. It's the error term. The multiple regression model is trained by finding the values of betas, coefficients, that minimizes the sum of squared differences. Okay, now why we square it? We are just coming into it. Squared differences between the predicted and the actual values. Now here, if you see, this is how in linear regression, just what we saw, it's a straight line because there are just two variables. Now here, if the number of variables are 3, you cannot draw a straight line, right? In a cube. Like, so it's a plane, looks like a plane graph. Okay. The line, the regression, it's not a line, it's a plane because the points would be scattered in 3 dimension. This is how just it looks like. Okay. It's pretty simple in the linear regression because it's just 2 dimension. But when the number of dimensions grows, when you plot the points, you're not drawing a straight line, you're drawing a plane. So that would be the regression plane. This is how, just a sample example it looks like. Now, there are 2 types of multiple regressions. One is ordinary least squares and generalized least squares. The main difference is ordinary least squares assumes that there is no strong correlation between 2 independent variables. So what it assumes is there is no relationship between x1, this feature, and this feature. They're very independent. Okay? But GLS deals with independent variables that may have some interdependency between them, and then it transforms the data. Okay, so GLS is more realistic. So to build a successful model, you should first think through the relationship between your variables. What variables are you using or choosing to predict the value of the independent variable? So say, for example, if you're building a model to predict the price of the house, bedrooms and how many people it can accommodate, instead of having as the 2 separate features, it can be combined into one because they're not very independent. So if you have more number of bedrooms, you would obviously accommodate more people, or you would be able to accommodate more people, right? So that's how you have to think. So these two have strong positive correlations. On the other hand, there is no relationship between the number of reviews and the number of rooms, right? So if a house has number of reviews or anything, so let's say if you are trying to rent on Airbnb, the number of reviews of the house, right? It has no relationship between the number of reviews and the number of houses because many people can write, many people don't write. What is ordinary least square? It's very simple. So let's say example, you're throwing a dart party, okay, at a giant board. Each dart represents a data point. And the bullseye is the perfect prediction, like you predicted perfect value of the y. Now, OLS is a special technique to aim to throw your arrows. It does not guarantee that you'll hit the bullseye every time, but you can get as close possible to the average. How is this done? First, what you do, you plot your points on a graph, like a scattered point graph. You just plot all the points. Now, OLS analyzes all the points and tries to draw a straight line that minimizes the total distance between the line and each data point. So this was what was linear regression about that we talked about. Then you square the errors. Square the error means, so let's say the distance between a point and the line, okay, is 2. So, and the other one is 3. Distance between the line and another point is 3. You will square it because you will eliminate all the small differences. And because when you see, when you square 5 and you square 2, the difference between the numbers is huge, right? Because 5 square is 25, 2 square is just 4. So that's why you square it so that you take the errors which are most important. Like, see, small prediction errors will always happen. So you tend to ignore that. But when you see a big prediction error, like, oh, it was supposed to predict 3, but it's a predicted 25. Why did it do that? You take that into consideration and try to rectify the model so that the sum is, when you add up total all the sum, it's the least one. Okay, that's the best model. Generalized least squares, it is an extension, as we discussed, of ordinary least square, but this takes into consideration the relationships that different predictors might have. Okay, it's an advanced version of OLS. And it does this by assigning different weights to the observations based on their variance and covariance structure. Now let's see multivariate regression in actual action. So here I have a Jupyter notebook. What you do, import pandas. This is a Python code. And from sklearn, you import linear regression. So again, it's still a linear regression, but we are using multiple factors. So price, this is what we are going to predict. So this is the data, like if the size, which means the square foot is this much, number of bedrooms is this is the price. So it's 1-to-1, okay? So if the number of bedrooms are 4, size is 2000 square feet, the price is 300K, okay? So this is what the data is correlated. And then we will give the number of bedrooms and size and see what the predicted value of the price is, houses. Okay? So you create a data frame using this. Data frame is nothing but just a matrix of price in this. What you do is define X, size and bedrooms, which are the predicting factors, and your predictor is Y. You create a linear regression model. You try to fit the model. See, now here, when you do fit, it's trying to do internally itself. Okay. Like beta 0, and try to determine the intercept, the coefficients, given these factors. So that is it to it. And then you're printing the coefficient and the intercept. Then for the new house, you give the size and the bedroom, and you tell the model to predict it. Okay? And this is just printing. So let's run it one more time. Let's do it. So here, let's run one at a time. Okay. You create a data frame. You can run each cell, right? You created a data frame. Create a model and fit it. Okay. Linear regression. Let's see if this just prints the data frame. See, data frame. It's nothing but just the matrix. Okay, price, size, and the bedrooms of the data that you created. Then you print the coefficient and the intercept. So this is the coefficients and this is the intercept. Intercept means when these two are 0, what will be the value? Okay. And this is the weightage of each. So we have two variables, right? Size and bedrooms. So this is the weightage of size and one is the weightage of bedrooms. Now, what you're going to do is predict. It's a warning, but we can ignore for now. And it says the predicted value of house with 1600 square feet and 3 bedrooms is 220.83. If we change this, so 1700 square feet and 3 bedrooms, hopefully the price it predicts, the model predicts is more than this. Okay, so let's see, more than 220. Yeah, see, 241.67. Right? So this is how you do multivariate regression. Okay, go ahead, practice this. Make your hands wet in the code using Python. It's easily randomly available. You don't even have to have Jupyter notebooks. This is online version of it. Go ahead, try it, change the values, and see it. All right. Thank you all for listening. See you all again in the next lecture with some more AI concepts. Thank you. Bye.